get started. Good morning, everybody, and good evening, everyone on the other side of the globe. I hope everyone's doing well today and had a good day in clinic. Today, we've got some very special educators here for you. We're very experienced. We have Dr. Dante, who is a physicist at the University of California at Irvine, and Dr. Soha, and she is going to be, or they are both going to be, she's a doctor at the Aswan Institute in Egypt. And many of you have met her already. She's one of your fantastic clinic liaisons. So we're really excited to have both of them speaking with you today. They're going to be giving you a lecture on radiotherapy acceptance and commissioning from the perspective of both a physician and a medical physicist. And my understanding is that they really want to encourage audience participation. So please don't hesitate to type any comments in the box or to let us know if you want to speak and ask a question or discuss a topic farther. So without any further ado, I'm going to turn the presentation over to Dr. Dante and Dr. Soha.
Oh, thank you very much, Tia. It is definitely a pleasure be here with you. And also I would like to say good evening, good afternoon, and good morning for all the members attending this lecture. So Dr. Soha, Ahmen, and I actually met last Sunday, and we were discussing about the dynamics of this lecture, and we thought that it would be, as Tia just indicated, far more beneficial if it is an interactive lecture. So I will probably kind of like begin with the first couple of slides here, and then when we start getting into the essentially the radiation oncologist aspects of the process, I mean, I will give that. Oh, hello. Oh, do we have? Okay. So I will pass that on to Dr. Ahmen to actually hear her comments on that. So the title, as you can see, is Radiotherapy Acceptance and Commissioning, a Physician and Medical Physicist Experience. Let's see, we can, okay. So the outline is fairly straightforward. So we are going to be talking about the decision process, and then from there we'll move on to the acceptance part and the commissioning part. Let me outline that on the commissioning, I am not going to go into all the details about the series of measurements that are required, because I mean that is essentially a lecture in itself, probably more than one lecture. So all those details, we are going to defer them for future lectures, but definitely I will be addressing some of the literature out there that could be useful. And talking about the literature, this is what we have. I mean, I'm putting some references here for your, for you to actually download. These are essentially task group reports from the AAPM, as well as the IAEA reports, as you can see here. These are actually quite useful documents for the process of acceptance and commissioning. More than likely, there are some more documents out there, but this could be a very good starting point. So let me address this part, and then we will be actually, co-sharing with Dr. Soha on this. So let's picture the following situation. So we are in the clinic. I mean, we've been doing a kind of like 2D treatments, and the time has come to actually implement new technology in the clinic. So for that to happen, we advocate to have like a very systematic and well thought out process to carry out that transition. So one of the other things that we were talking about is that within the clinic, we would recommend to actually have like some sort of like a steering committee formed. And this can be within the members of the department, and we will be going into that in more detail. And this steering committee can be addressing essentially the points as to what are the new treatments that we want to offer, or maybe treatments that we are already offering, but probably are limited by some of the technology that we currently have. So we would like to say offer treatments using flattening filter-free beams. Our current equipment does not offer that. Or we would like to integrate brachytherapy, to our practice. So all these different issues have to be addressed, and along with that will correlate with the amount of extra or maybe existing personnel that you would have in the clinic. So this is something that probably it is not for, say, a radiation oncologist or a physicist to be addressing in detail, but maybe for your department administrator. So, and that would kind of like indicate or allude that probably members of your steering committee should involve management in here. Now, along with that, back to the technical part, any kind of ancillary equipment. Okay, say we would be planning on purchasing a brand new accelerator, but it is not only the accelerator that is that will be needed moving forward. I mean, you need to have probably some quality assurance equipment, maybe immobilization equipment, when we are dealing with patients, and all these different points that I indicate here. We need to have the right professionals within our department addressing them in detail. A very, very important point, personal education and training. This is a key element, okay? And we are going to be touching on that a little later, but this is definitely key. And also this correlates with the essentially the timeline when this education and training is it's provided. Oftentimes, and this is from actually experience within my clinic here, we have received the education probably months in advance from actually acquiring or having the machine up and running. And oftentimes what may have led to is that probably you start forgetting some of the other key elements of what you learned. So anyway, so those are the things that you need to probably keep in mind. And we will be definitely repeating this in more detail as we move forward. Budgets, cost, and expected revenue. This is something also that you need to address. These are actually, again, very key elements, and this is probably something that comes to, or has to be brought into the decision making by the management within your department. And finally, another point, very important, is the implementation timeline. So we need to be cognizant about the amount of time that it will require for the company to install the machine, then the time that it will require for the medical physics team to actually do the acceptance and commissioning, and then from there has to be a gradual approach as to the kind of treatments that you will be implementing. So anyway, those are some of like the key elements that have to go, and probably more in the this decision process part. So. Okay.
Dante, I don't mean to interrupt. Can you switch full screen mode for your presentation?
I tried to do that, and yeah, and this is what I've been having a little bit of difficulty. So you cannot see the full screen as it is. Let me stop sharing. Hold on one second. Let me give it one more shot.
That's much better.
Much better. Okay. All
Thank
right.
you.
So yeah, no worries. Let's see. Let me see if I can. The point is, I'm in full screen. Well, maybe. Okay. So this is how I'm gonna have to move it. Okay, that's fine. All right, so now you can see the title of the presentation, the outline that we went to, references that I addressed, and I just finished actually addressing each one of these points. Now, was the audience able to see all the key points that I had here before the maybe with my screen being cut off? I mean, probably something got lost. Everything looked fine.
I think it was visible to everyone. It just wasn't in presentation mode.
Got it. Okay, so we are good. All right. So as it is, the regarding the recommended committee members, and this is something that again we Soha and I actually decided that this should be the key members and move. And I forgot here to add probably even patients could be included, or from a survey given to patients. I mean, that information can be included here. So we have here a designated radiation oncologist to be part of this committee, a designated medical physicist, designated radiation therapist, and administrator. Now, why do I say designated? Well, the thing is that this designated radiation oncologist, it is assumed that he or she has met with her peers, and they have talked among each other, at the peer level, as to what are the treatment techniques that would be more appropriate, essentially, and the details about these treatment techniques. Example, let's take brachytherapy, for instance. What kind of brachytherapy treatments would be appropriate based on the patient population that you are seeing? Is it going to be tandem and ovoids, interstitial treatments, maybe cylinders? And say, if it happens to be in interstitial treatments, I mean, do we have access to OR facilities? Because placement of needles, for a patient, for say a gynecological procedure, I mean, it cannot be done in a radiation oncology facility. I mean, typically you want to do it in an operating room setting, with the anesthesia team available in case of any unexpected situation during the procedure. So things like that. This is something that is purely within the medical aspects. So the radiation oncologist, prior to this meeting with the rest of the members, they would have met with colleagues and determined, the appropriate treatment techniques and all that should be required. Regarding the medical physicist, now the medical physicist, we need to start thinking ahead. We need to start thinking about the different kind of technology that exists out there, and also not only that, but how compatible that technology is with what we may have in the clinical ready. And also to keep in mind about the patient load that we are going to be seeing. So if we are talking about for instance, I mean, treatments where, or patient loads where we are treating like 100 patients a day and we have like 2 or 3 shifts, well, maybe, we might need to start thinking about machines that can actually not only take the load, but also along those lines, the kind of service maintenance that may be required. And this has to be included in the budget up front, just to name a few. And I have other elements about, say, validation for treatments and stuff like that. Radiation therapist. As I already indicated on my previous slide, we have the radiation therapists are going to be the key team members to determine the kind of immobilization devices and potentially, application of treatment protocols for these new treatments that we are envisioning to have in the clinic. So they need to do their homework. They need to do some kind of maybe vendor search or vendor a product research as to what's out there, what kind of what is available in the region where you're at, definitely costs, and whether the supply can be regular. There would not be any kind of failure in supplying material that would be needed for patient treatment. An administrator is also a key member of the team. The administrator will have to look into, as I indicated before, the timelines. Timelines are very, very important. Potential overtime, when it comes to say, radiation therapy staff, medical dosimetry staff, potentially, whether, we are going to need extra manpower, to hire more people since we are offering more sophisticated treatments. And not only that, but maybe, if we need to have like 3 or 4, say, radiation therapists per machine, we need to know what the expected patient volume will be. And more importantly, what would the expected revenue be? So with that in mind, I would like to probably hear from Dr. Soha about the, what, if she can add to this, the responsibilities, let's say, from the designated radiation oncologist.
Yeah.
So.
Thank you, Dante, for you cover all the points that really discussed with me and you last Sunday. I would like to say hello for everybody and say Salamu Alaikum. This is the most popular greeting in Arab countries. So let me say, sum up what you said in the past couple of slides in Arabic in order just to make it clear for everybody. لما بنيجي نحط خطة أو plan عشان نبرشيز أو نشتري لينك جديد بيبقى كل اهتمامنا باللينير نفسه. أوكي أنا عارفة إنه في سنترز كتيرة دلوقتي في العراق ريزجاري Alexandria and some others are moving towards having a new machines. So what we are going to stress today and the message to be clearly sent that we are sharing together this decision. احنا كلنا لازم نبقى كوميتي واحدة. أنا عارفة إنه في البلدان العربية مش دايما بيمشي الحال كده، بس احنا هنا جايين علشان نأكد على المفهوم ده إنه الستيرينج كوميتي أو decision making كوميتي أو اللجنة اللي هتقرر إحنا هنجيب which of which type, which service, and which kind of technique that we are in need really. I know most of you or even all are merging from 2D to 3D, so we are not a stage to have a fancy SRS or SBRT or brachy or something sophisticated. We are now merging to have a classic, good, a very a friendly machine of 3D and IMRT, and that's great to have it for now. The decision has to share between radiation oncologist, the physicist, and the therapist, and even the administrative HR. We are all together are sharing this decision. ده مهم جدا. احنا هنمشي الاسم ده ازاي؟ emerging from 2D to 3D هيخلينا نشتغل ساعات أكبر. في learning curve هنبقى بطاء في الأول، هنحتاج manpower أكتر. الكلام ده كله لازم يبقى بيتناقش على كل مستويات الاسم، الدكتور، الفيزيائي، الثيرابيست، وكمان الادمنستريتيف. ده مهم جدا، اللي قاله دانتي ده يعني كلام مهم. And you have this message now to deliver it to your heads, and also some of the managers are with us now in this meeting. So every single tiny comment from maybe resident is adding value when you are purchasing or planning to have a new machines in your department. So this is a sum of what Dante said, because this is a very important message to be delivered to all of us. And regarding the radiation oncologist, if I'm your shoes now and أنا دلوقتي جاية عايزة أروح سنتر جديد أو أنا السنتر بتاعي عايز يبرشيز، أحسن حاجة نعملها إن إحنا يعني نتبادل الخبرات changing the experiences. أوكي، ما فيش أي مشكلة إن إحنا نتنقل لسنتر قريب مننا. مثلا العراق عايزة تشتري دلوقتي لينك، ممكن حد يجي زيارة للأردن أو حد من الأردن يجي زيارة لمصر. أنا عارفة دلوقتي التنقلات مش عظيمة، بس in case إحنا بنتكلم في وضع optimum، فإحنا ممكن نستفيد من خبرة الأماكن اللي حوالينا اللي هي قطعت شوط وجابت الأجهزة واشتغلت عليها وعملت تريننج فيها، ونطلب منهم دعم وتريننج and so. Estimated number of patients is very important. I have to estimate and put in mind always that whenever there is a new center, there is a huge gush of patients will facing you. أول ما السنتر بيفتح، إيه ده في سنتر فتح جديد، هتلاقي gush of patients. So you can double the number that you are treating now with 2D after you are announced that you open the service with 3D. So you have to put in mind, you cannot accelerate your machine more because sorry, people need to have their training. Yeah, sorry.
Yeah, maybe we can mute, you know.
Okay.
Yeah.
So people can, you cannot push the people to be accelerated or to work in fast way at the beginning. So the optimum thing is to have an extra shift. بدل ما نشتغل فترتين نشتغل 3.
بتيجي على الزلط كده تكون اوضح.
Okay. And the training is very important issue. And when I discussed with Dante the topics of this lecture, I asked to stress upon the training, because when we sign the contract، لما بنيجي نمضي contract مع الشركة، احنا مش بنشوف الشركة وفرت لنا ايه training كويس. احنا بنشوف ال facility, how many TPS, the dosimetric tools, the maintenance, and so on. So the part of the training that the vendor is going to offer us is very, very, very important. Even if I'm the decision maker, I will put the penalty or the downtime penalty in the form of training. لو الجهاز ده عطل أكتر من اللازم، في ناس بتزود فترة الضمان، في ناس بتزود الاكسسوارز whatever. أنا شخصياً لو أنا المسؤول، أنا هزود فترة التريننج. Okay, the training is very important, and even the training has to be sustained. يعني إيه؟ يعني هو لازم يبقى all through فترة التشغيل. مش كل training يبقى في الأول وأنا ما اشتغلتش، فأنا لما أجي تست المكنة اللي أنا شغلتها أو TPS أو whatever كله في مكانه، دكتور أو فيزيكس أو ثيرابيست، بتظهر عندي أسئلة كتير جدا، بواجه حاجات في بداية التشغيل. بعد كده لما أخد الثقة وأشتغل، في حاجات كتير بتظهر، ببقى محتاجة التريننج ده يتعاد تاني بشكل تاني خلاص بعد ما أنا اشتغلت. فناخد بالنا when we sign the contract that the point of the training has to be sustained periodically, every 3 months, every 6 months, and so, because this is a very important. And what else? Provide a summary list of points above for the committee. Everybody has to put his own list, and the designated radiation oncology collect the whole comments from all the colleagues in the department. Everybody has to share, everybody has to put his experience. If we have colleagues that travel abroad, I know that from Alexandria, there is many of our colleagues traveled and experienced this machines on US or in Europe. So they can recommend, because they know the culture, where they live, and also they had an experience abroad of what should be. So they can make a very nice mix we cannot neglect those people who work and trained on such a machines or such an atmosphere or workflow. لازم ناخد منهم الخبرة ولازم نشركهم معانا في القرار، لأن هم أحسن ناس يقولوا لنا نعمل إيه في ظل الظروف اللي إحنا يعني ظروف البلد، ظروف المرضى، الأعداد اللي عندنا. Okay, you can have the most fancy and highest technology machine and you cannot use it properly. So وده حصل في حتت كتير نعرف، جابوا أحسن أجهزة بس ما شغلوهاش كويس. Okay. So I finished this part, Dante. Okay,
Yep.
you can.
Yep.
You can go on.
I'll carry on.
Yeah.
Thank you, Dr. Soha.
Okay.
So I would like to address a little bit more about the responsibilities of the so-called designated medical physicist.
Mm-hmm.
So, you know, I am a physicist here at UC Irvine, so I can probably address this in a lot of detail and probably spend quite a bit of time. But I'm going to try to be very concise, very succinct on these points. We have the expertise to actually do some kind of comparative analysis of all the type of different radiation therapy technology that is on the market. And we need to take the time to identify what the pros and cons are for the equipment available. For instance, I mean, the pros and cons have to be in the context of the patient load that we are estimating to have. So as such, I mean, you know, there are some equipment out there that probably the design that they have, it is may not, I don't want to say that is either suitable or not suitable to actually handle the patient load. But along with that, I mean, we need to be cognizant on how things, you know, the machine design, and most importantly, the type of maintenance that may be required down the road. I can give you examples, at least, you know, from clinics in Peru that in Latin America that I talked to. I mean, colleagues from that region. Essentially, we were giving information that probably some of the machine broke down. I mean, some of the other main components had to be repaired. But of course, the machine was, when it broke down, it was essentially down for like about 2 to 3 months because there was insufficient financial support to actually get the parts. In other words, I mean, they did not have like a maintenance agreement, service agreement with the other company. So there were issues that came to that respect that had to be addressed, or well, you know, just for the sake of saving times up front at the time of the other contract. I mean, they were not taken into account. The other thing is also we need to identify the compatibility, and I mentioned this a moment ago, but that is a very important point. There are a lot of equipment out there that is probably self-sustained and maybe incompatible with some of the software or maybe even some of the existing technology that you may have in your clinic. Well, if we want to have like an integrated department, I'm not so sure if that may be one way to do it. But if we want to diversify it and have different technology available, then probably that could be acceptable. So those are the things that us as medical physicists, we need to bring to the table. We need to identify it, and we need to address, you know, essentially the pros and cons so that everyone else, administrators, radiation oncologists, radiation therapists, can clearly understand benefits or maybe benefits or not so many benefits of the equipment at hand. We need to budget for essentially additional quality assurance equipment. We are talking about detectors, electrometers, phantoms, because it will be our responsibility to actually do the commissioning and eventually end-to-end testing of a specific treatment technique and all. So for that, we need to have the necessary equipment to actually do a very reliable set of measurements, you know, which will give us the peace of mind that we did a good job. So this is something that we would have. Then, of course, the addressing the suitability and existing availability of CT scanners. If we are transitioning from 2D to 3D, this is actually a critical element. Are we going to have our own CT scanner available in the clinic? Are we going to be sharing or getting all the our CT scans from our radiology colleagues? So this is something that we definitely need to address. I can tell you from personal experience here in our clinic at UC Irvine, in the early 2000s, all our CT scans, I mean, we were doing it in radiology. So we had to go there, we had to actually talk to the people in charge in radiology to allocate a certain amount of time so that we can do our CT scans. I'm not so sure what the situation would be in your clinics, but this is something that probably needs to be identified. And then once again, what was indicated by Dr. Soha, education and training is a key element. And also, you know, maybe for some treatments down the road, we may need to have a certification, etc. You know, from an external institution. Here in the United States, we have IROC. And typically the certifications that we would get from IROC are from, say, IMRT treatments, SRS treatments. This is a little down the road, but anyway, it is something worth mentioning. I'm not sure if within the audience we have radiation therapists, but if we do, these are some of the key elements that I enumerated for the responsibilities on the radiation therapy side. Indication of different immobilization devices. I'm not going to go into too much on it because, I mean, we have already addressed it. But this is essentially some of the critical, and I would say really critical information that we need to have. For instance, just to give you an example, here at UC Irvine, in one of our LINACs that we have, an ancillary equipment that we use is this optical surface monitoring equipment. So the system actually provides with a real-time position monitoring of a patient. Now, typically, one of the sites that we monitor happens to be around the region of the head and neck. So we utilize these masks that have the whole face open, okay? I'm not sure now if in that region of the world now those masks are standard, but this is something that, for instance, I mean, has to be addressed by the radiation therapy group, because there are different masks that often an open face design, but may not be rigid enough. Within our radiation therapy staff, I mean, we were using a vendor that provided those masks, but it was essentially the mask, the region of the frame around the chin was very flexible. I mean, the patient could move his or her face very easily. So it was not rigid enough. So we had to, our chief therapist at the time, I mean, had to do a search and actually find a different vendor that supplied immobilization devices that were of better quality. The other thing is also regarding other immobilization systems, such as boluses, backlogs, etc., and also equipment too that would be needed for to make them. You know, water baths, this kind of like a pump, you know, to suck out all the air for a backlog, etc. And once again, for them also, education and training is a key element. Another example of that, let me share with you. I did a consulting work in Mexico about a couple of years ago. And yes, they were transitioning from 2D to 3D. One of the elements that that we noticed was a very short, it was kind of like we saw a lot of shortcomings in the process was at the time of using the OBI system for patient positioning prior to treatment. So if we are transitioning from 2D to 3D, we are going to have the ability to generate digital reconstructed radiographs, in other words, images from the treatment planning software. And those have to be transferred to the treatment machine. and correlate that with a say that the KV images that the machine will be able to provide for you. And that way, utilize those images to actually position the patient correctly. Now, but there has to be a process. We are not going to go into all the details of what that process is, but what I am trying to illustrate here is that that is part of the training. That is something that has to be addressed at the time, as part of the education and training material that must be provided to the clinic. Okay, so moving on, the administrator part of it. I know this is probably a very dry topic, but I'm telling you guys, this is very, very important. And I can tell you also from experience. So an administrator has to be part of the decision making, because it is the administrator that is going to somehow fight with the powers that be to allocate the money that we need, not only for the equipment purchase, but for subsequent maintenance or ancillary equipment or whatever day-to-day operation expenses. So the administrator has to be part of it, and this administrator has to be very knowledgeable about the needs of a radiation oncology department. Oftentimes, we run across cases where typically an administrator happens to be a person that is does not have any information or is totally unrelated to radiation oncology. And unfortunately, they are the ones that are making the decisions for radiation oncology. And that actually, the end result to all of that is a very detrimental or a highly probability of detrimental results. This is something that we need to avoid at all costs, okay? And I am not sure, what the how the organization in your clinics is, but this is something that probably you guys need to identify: the physicists, radiation therapists, definitely the radiation oncologists, and actually educate this administrator as to what the needs are in the department, and also primarily what are the key elements that we need to have if we are going to adventure ourselves to purchase a new kind, new technology for the department. And here I am enumerating all the key points, to make it more detail as to what I am talking about. Okay, so I'm not going to go into all these points in great detail. Well, take it back. I just want to emphasize this part: acceptance commissioning and regarding downtime. Oftentimes, and actually I have to, on occasion, I would say radiation oncologists also do the amount of time that it will take to actually do the acceptance commissioning. Oftentimes there is this misconception that once you do an acceptance of the machine is ready for treatment. That is not true. That is actually, if that were to be the case, if this is something that you are doing in a clinic or have done in a clinic in the past, that is a recipe or a potential recipe for disaster. That should not be done. The acceptance does not mean that the machine is ready to be used for clinical operations. We need to actually, the medical physics team has to carry out the commissioning. This is a process that can take, depending on the complexity of the machine, probably about on the order of a month, maybe a little bit more, and has to be done very thoroughly. It's a collection of data. We are going to go into that in more detail, but this is something that within the decision team, our colleagues, administrators, radiation oncologists, radiation therapists, they need to understand that this is a very important aspect, and definitely is going to take a little bit of time. So we need to be cognizant of that. And of course, as I indicated here, allocation of some percentage of the revenue for operations, expenses, and upgrades. I don't know if maybe the audience has any questions. Is it possible if we can do it, maybe allow the, rather than text, if we can have probably chat and talk. I don't know, there may need to be a moderator. Maybe Tia can jump in and become our moderator, but rather than looking at the chat. Would that be possible, or maybe not?
Sure. Yeah. So there haven't been any typed questions yet, but does anyone in the audience have any questions that they'd like to discuss at this point in time? Either you can unmute yourself, or you can raise your hand and I can unmute you.
I have the feeling that, what we have discussed so far, this is something that in one way or another, all of us have been familiar with. Okay, so this is not probably anything like totally brand new. It's a matter of what we have done is putting it all in a more organized manner. And so if you guys in your clinic are about to embark on the purchase of a new machine, or are in the process of acquiring a new machine, I don't know, maybe you can share with us your experience, and we can comment on that. Well, I guess
most of the centers is merging from 2D to 3D, so they don't have the full experience or what's going on the 3D area.
Okay. Hold on, just 1 second. Oh, I'm in a meeting. Sorry. Oh, so sorry about that, guys. I mean, I had someone knocking on the door. Yeah.
One of our colleagues, what is the accepted machine break days per year? Well, actually, there is no acceptance for break, but
accepted
machine break days. So,
well, actually, I think I may have an answer for that. Essentially, like companies out there, Electa, Variant, maybe others, they indicate that any kind of downtime, they supposed to have a guarantee of, let's call it machine uptime, on the order of, 97% in a year uptime. So about 3% would be essentially allocated to machine downtime. And and this is something correlated to essentially your the treatment, treatment days that you would have allocated. I mean, here in the States, or in here at UC Irvine, we treat Monday to Friday only, is one single shift from like 7:30 in the morning till like about 6 o'clock in the evening. And so essentially 3% of that throughout the year, I mean, it would kind of like come down to maybe, an hour or so of the machine not being operational. So now, but then again, that is the reality in the United States.
3% from the total time annually?
Yeah, that's I could be wrong, but anyway, I do recall that that was something that was indicated to us.
I'll just say in Arabic in order to be clear. Dante بيقول إن الوقت المسموح به للداون تايم هو 3% من وقت التشغيل. يعني إذا احنا بنشتغل مثلا 5 أيام في الأسبوع في السنة، يبقى نحسب منهم 3% هو ده الوقت المسموح للداون تايم. Okay? Just to be clear. Okay.
Sure. Yeah. So, but then again, that is going to vary from region to region. Okay. So what I just indicated, that was for the United States. Okay. And primarily, and here, I'm not advocating any vendors. I mean, this is something that we got from Variant. We have Variant equipment here in our clinic. I am not sure what the policy is for Electa or for Accurate machines and all. And the other thing that probably in your centers, something that you really need to keep in mind is that may be different, where you're at. And that is something that probably you need to, and maybe this could be a responsibility for the medical physicist, be aware if there is a kind of a dedicated or centralized, technical support from a company within the country you are at. For instance, let me give you an example. In Latin America, if you go, only Brazil has a variant offices in the country. Okay,
Yeah.
the other countries, yeah, do not. They rely on third parties. I'm sorry. Yeah, go ahead.
Mean hub for the spare parts, or just a managerial office?
It is correlated. I mean, actually, for be able to have spare parts, I mean, distributor of parts. So for Latin America, for instance, the hub comes from Brazil. So it is from Brazil that if, say, the machine breaks down in Peru, and it had to do with, say, the waveguide. Okay, so they need to ship a waveguide from Brazil to Peru. Now, so that is going to take a little bit of time, because depending on, I think the offices, variance offices happen to be in like Sao Paulo, if I am not mistaken. So a flight from Sao Paulo to, say, Lima, Peru is, I think, takes about, 5 to 6 hours. It's not like an overnight, well, it could be an overnight flight, but, it's a little bit of time. I am not sure what the if something similar happens or exists in the Middle East.
Yeah, in Egypt now there is ongoing, maybe because of the corona issues, but when I was in the last Astro was held in Chicago. I was there, and I met the whole guys of Electa, and the local people from Electa also in Egypt, and they was processing or even ended up to have a hub for spare parts for all Electa machines located in Egypt that will serve the whole North Africa and Arab region. So this is a good achievement. I think they did it already, or just about to finish. The delay was just because of the COVID, no more. But we will have a hub for spare parts regarding Electa. Another thing I want to commend for people who are ongoing to have machines or planning to have machines. If the whole country, or let's say 70% of the whole country is, let's say, I don't want to say such a vendor, or let's say 70% of the country is using Electa, it's not recommended to come and have variant, because the experience in maintenance, having spare parts, asking help for colleagues and friends in the physics, oncology, or therapist part, have a training, will be much easy if they. I don't want people to be pushed to have such a machine from vendor, but this is really important, because I face this here in my country, because when the people is hugely trained on such GPS or machines, it's easy to exchange experience between each other, and easy to deal with the vendor and change the experience in contracts and so on. So what do you think, Dante?
Yeah, there is definitely an element to that. I think if yes, I definitely agree with that. It is something that you need to keep in mind. At the same time, also, is we need to be cognizant, as I indicated before, about the technology limitations too. So what I'm getting at, and this is kind of like getting into some details and experiences that I've heard from others. If we are treating a very large patient volume, very, very large. I'm talking about 100 patients a day or so. Machines, and this is on the technical side and for medical physicists, machines with say magnetron type systems. The lifetime may be a little more limited than say machines with klystron type systems. So I would say that probably our medical physicists in attendance may understand what I am saying in a little more detail. So now, is one better than the other? I guess, it's up to you to make a decision. But one thing that I would definitely recommend is that to actually look at the pros and cons of each one of them. And based on that, look at potential elements such as the service that would be required. And I'm bringing this up, I'm hammering on the patient volume because I have a very strong feeling that you guys probably treat a very large number of patients a day. It is probably kind of like drawing a parallel, very similar to what I've seen in South America, in Latin America. So anyway, that's where I am coming from. That's what I am bringing to the table. Anyway, okay. I just wanted to probably continue with a little bit on the presentation. And Tia, we only have 1 hour on this, right? Or
yes, I think we can probably extend a little bit longer if others are available to stay, but we want to try to keep it within an hour. We do have one more question that from one of our from Dr. Cutter. She asks, is there any possibility that you can have a legal procedure that will include the signature of all parts that you mentioned? This way the members will have a point of view in what concerns buying or dealing with a new technology.
Oh my goodness. Wow. That's a very good question. I don't see why not. But then again, I mean, I think that has to be probably addressed within that clinical setting. It is definitely a very good idea, because I think we need to be very transparent, and what is being proposed here with this suggestion, I think that definitely could help towards transparency. I personally don't have any experience on that. I mean, here within the clinic, I mean, I don't want to say that we are 100% transparent, but well, there is some level of transparency. We know what we want, and we communicate that to the vendor. And at that time, on the vendor and on the contract, I mean, all those points are clearly spelled out. That I can tell you. And so yeah, I'm sorry. I'm sorry. I don't have any a better answer, but it is definitely a very good suggestion. So.
Yeah, I certainly don't have any experience myself as an early career physicist, but my experience with vendors in general has been that to communicate with you. And so if you have questions about what type and ask.
That is true.
That, especially if you just communicate with them like the concerns of your center and your country, and I think that open communication, like just so that everyone understands the page that you're coming from, they would probably be willing to work with you.
No, they do. They do. I mean, we are regular. I mean, those are included in the contract. But the key to all of this is it is up to the client, in this case, your clinic, to bring them up to the table, because the vendor will not be the ones actually bringing those key points, to the table. So that is the homework that you need to do. But Tia is absolutely right. I mean, they can be included on in the contract. More than likely, if the vendor wants to have your business, they will do everything possible to accommodate you. but you need to take the initiative to actually bring those points up. Yeah. Okay, let me carry on real quick because I'm showing you here a table. I think this table is quite informative. And for those of you that are transitioning, okay, maybe this can give you an idea from the treatment planning point of view, okay? I am not addressing Linux, but just the treatment planning point of view. You have here all the different treatment plans. Maybe there are more here, but I would say that these are probably the ones that we know the most. You know, you have Philips. I mean, this is Philips Pinnacle variant with it's a Eclipse, Electa with Monaco and XIO, Ray Station, DAO, etc. Now, here you can see, you know, all the different capabilities, say treatment planning capabilities that you can have is essentially, if you're planning on doing external beam radiotherapy, and also you want to do brachytherapy as well, I think it makes the most sense to actually have a treatment planning platform that would allow you to do both, okay, rather than have it, you know, like a separate treatment planning. So anyway, it is something for you to, you know, some food for thought and to think about. Okay, so all right, now here I'm gonna go very, very quickly, and this is actually very, very important. So what I am calling here on the TPS, the pre-acceptance. And here I am addressing it in terms of the treatment planning software. You know, it was that my previous slide was a segue into this one. So let's say that you on the treatment planning software, so these are the different elements that you identify that you want to have on your software. Okay, you're going to be doing 3D conformal planning. You want to do eventually IMRT, BMAT, all these very fancy treatments. You also want to do brachytherapy. And you want to have very sophisticated calculation algorithms available. And also you want to be able to, with the this software that you have identified, and say with the Linux, you want to be able to actually, for the software to work in conjunction with maybe other softwares out there. This is the MIM software, MIM, the multi-imaging modality co-registration for image fusion, and some other capabilities, as you can see here. Okay, well, anyway, so these were elements that were identified. So, okay, so we are gonna take a big jump here, okay? And the big jump is that, fine, you identified all the things that you wanted. You had, you worked out an agreement with a vendor. You indicated all the on a contract that the vendor and your calls were indicated in that contract. And maybe, you know, what Dr. Qatar, so included in the contract. Great. So we are, it was fully transparently done. So we are good. Now comes the acceptance. What is the purpose of the acceptance? We want to make sure that all those elements that were in the contract is exactly what we are getting, okay? We are not getting shorthanded on anything. So this is the time when it is the responsibility of that vendor to actually show us point by point all the different parts that that we request, okay, that we purchase. So this is what I am indicating here. So you want to confirm that software, hardware perform according to the specifications, and you have all these elements here as to what the purpose of the acceptance is. Now, the process can take can take a little bit of time, can take maybe a week to 2 weeks, okay? And it is, typically the acceptance is done by the medical physicist. And here I have like about a week, okay? That's the reality. So these are the 10 key points that, that a medical physicist wants to actually cross-check on the system that you just purchased. So the CT input, this is in terms of for the treatment planning, okay? The anatomical description, beam description, calculations, dose display, etc. So these are the 10 points for the treatment planning part. For the machine part, well, it is probably, well, I don't have them here with me. I have to be transparent, okay? But also there is a set of different points that are included. I'll be more than happy to send those to you if it is requested. But this is, I mean, I am focusing now on the treatment planning part. I assist that connectivity. You want to make sure that you are able to export a CT scan from either a scanner in your planning software. And right here, I just added kind of a configuration as to how this is done. This is actually based on the variant system. I'm not going to go into all the details, but at this point is essentially you want to make sure that you scan a phantom and that was sent to the treatment planning software and there was no issues, no information on the imaging that got missed. That's in a nutshell, you know, what you want to verify. Now, what do, okay? So in this particular example, if you see here on the photographs, I am in solid water and I am using a ruler. Okay, why is that? Well, the ruler here, you know exactly what the dimensions of this ruler is, okay? And you also know the dimensions of the solid water. So when you carry out the scan and then you export that CT scan to the treatment planning software, you can actually verify the fidelity and the quality of the image by actually within the software, you know, utilizing the ruler, sure that you know what the ruler tool measures is the actual dimension of the ruler that you just scanned. You know, simple things like that, because I mean you're not going to be like actually be checking those things. Okay, so kind of like points. Now for the sake of time, I am enumerating here some of the other verification elements that you need to look at in the within the treatment planning software. And this right here is essentially a verification of the different contour tools that you have available. All treatment planning softwares nowadays, I mean, they do have that. And here is an example of the different contours that you can analyze. In this particular head and neck case that I am showing you, for instance, I mean, you have like all these contours that were done. Now in here, in this other image, you have like some of the modifications that were done to the contours. Now this is the part that actually. Oh, okay. Oh, we have some background. Well, in this, oh, can we do some muting? Okay. Anyway, so those are the another verification. We have the image fusion, and I'm just going to take 5 more minutes, and then probably we can wrap it up. The beam description. So essentially the different orientations. This is actually quite important. You know, and here is a correlation on the treatment planning part with the beam. The settings that if we are addressing the treatment planning software, it has to be exact match to what you have in reality. In other words, I mean, what I am getting at is that the definition of the beam scale that you were using matches what you had defined in your treatment planning software. So those are key portions. And I'm just gonna skip this part for the sake of time, and the part of the commissioning. So as I indicated, the commissioning portion of it is essentially the collection of data that you're going to be using for your treatment planning part. In other words, this is your actual data that eventually will be used to generate all 3D conformal plans, etc. So as I indicated, it can take 6 to 8 weeks, and this is from a TG-T45. I know it is outdated. And here are the different numbers of measurements that you can take. So in reality, if we look at the number of measurements, if we look at for one X-ray beam, essentially for one single X-ray beam, you are going to have like about 363 measurements to be done, and about probably a little over less than half for an electron beam. So if you have a machine that is going to have multiple X-ray beams, on the commissioning aspect, I mean, you are looking at over 2,200 measurements that you will need to be done. And this is something that has to be done because it is the data that you're going to be utilizing in your treatment planning software. Okay, I think I'm going to stop here. I have some more material, but we definitely ran out of time. So I apologize for giving you an incomplete presentation, but I thought that it was definitely very important to actually hammer out the initial portion about the administration aspect of things and all. Thank you so much.
Soha, do you have anything else that you'd like to add?
Yes, I would like to say that the particularly acceptance can be done by our trained physicists. An easy task for physicists who never agree or not with that. I mean,
yeah, well,
it's not a must to have the commissioning and acceptance by our physicist. We can have it by the vendor physicist or somebody else.
Oh,
that.
Yeah,
Because
right. Yeah, so there are a consultant physicists or companies, I should say, that where outside physicists would come and do the commissioning for you. They would have a team of like about, I don't know, 5 or more physicists that work literally around the clock to actually collect all the commissioning data that is required. And then after that, they would configure the treatment planning software for you. Because in a busy clinic, the clinical physicist probably may not have the time, or I would say, you know, the strength to actually take care of the clinic, and then after that, proceed to do the commissioning. So yes, there are some outside companies out there that would provide the commissioning service, and actually they do a very good job. I mean, and what you do afterwards is just you proceed to verify essentially do some kind of like spot checks, you know, specific dosimetric aspects. So yeah, that is correct. Now I have a question here from Iman. Can you repeat commissioning? Yes, you could. As a matter of fact, I mean, like in our clinic here, as part of the biennial, well, we are not repeating the entire commissioning, but the biennial is sort of like a mini commissioning that we do. And we do take PDDs, profiles, profile data. The only thing that probably and cross-check some of the output factors as well. So the answer to that is yes. Yes, you can repeat the commissioning. But typically it is one time is typically is sufficient. The only, oh, well, let me add to that. The only time that you may want to repeat the commissioning or cross-check things is if you have had a major the gun and stuff like that. Yeah. Any other questions?
Yes, thank you very much.
Was that a question?
Yes. Yes, I am from Yemen.
You're breaking up.
Could you potentially type your question? It's very difficult. Yeah, it's difficult. The connection is not great.
Okay, thank
Oh, there is a comment. This means we be working 5 to 6 weeks after installation. The answer, yes, unfortunately. Keep in mind, you have to, it is the beam commissioning, but also you may need to commission the OBI system as well. So yeah, it is a lengthy process. This was posted by Roshgard. Is the recommissioning must done if planning system change? Not necessarily. I think if you happen to have the data collected from your machine, that data could be entered into your new treatment planning software. So essentially, if it is just a treatment planning that changed, but not your machine, not your Linux. Yes.
So Dante, what is the spare part? If I changed, I have to go.
That's a good question. Typically, it is recommended that if you were to actually collect the some of the data, oftentimes, I mean, what the clinic does is, I mean, they do some spot checks. Rather than take the time
coming in the morning and found the guys is having the BDD again and everything is again. I think, well, what's happened here is that we repeat the commissioning because at this point we have to repeat it. So I'm just sending this message for colleagues. Sometimes critical spare parts like the waveguide needs to repeat your commissioning and BDD.
Yeah, right. I mean, but then again, as I indicated, I mean, not many clinics take that, or not everyone kind of like is in 100% agreement with that option, because oftentimes, you know, like the waveguides, and we had this done here at a UCI. they have a very, very tight specs, okay? So the replacement of one waveguide versus the other, I mean, like the similarities happen to be just about, say, they're like 1-to-1 just about.
Mm.
So because of in that approach, I mean, what the service engineers can do is they can fine tune it to exactly be what it was before. So many clinics opt for just doing spot checks rather than a true recommissioning. And at the time here in our clinic, I mean, well, it was we had a lot of patients, so we at that particular moment we proceeded with the spot checks, but over the weekend we did do some not a full-blown commissioning, but kind of like a mini commissioning. In other words, I mean, we investigated PDDs for all the energies and profiles, things like that. Yeah.
Okay.
Why there is a difference in duration of commissioning between variant and other? How many algorithms calculate on TPA should be? Okay, I am not commissioning duration between variant and others. I think that commissioning duration is dependent upon the number of beams that your machine is producing. Here in our clinic, we have a TrueBeam STX that has 6x with flattening filter, a 10x with flattening filter, a 15x with flattening filter, and then we have a 6 FFF and a 10 FFF. So we have a total of 5 different X-ray beams plus 8 or 9 electron beams. So to commission all of them, that actually will be determining the amount of time that it takes. If other machines can only produce, say, 2 X-ray beams and maybe just 5 electron beams, well, you know, potentially the commissioning can take less time. So it is dependent on the number of beams that you have, and of course, if you are going to be utilizing all the beams or not. You know, some centers don't, for instance, they don't use any of the electron beams, just only the X-ray beams. So that would reduce your commissioning time. In commissioning, we use cap tool for each energy. I'm not so sure what cap tool means in this. The commissioning is done in water. I don't know if you can elaborate what the cap tool you're referring to is. Why there is a difference in duration of commissioning between variant? Okay, I already answered that. And how many algorithms calculating TPA should be? Typically, the algorithms, I am familiar with Eclipse. We have available the AAA algorithm, and we have Accurates as well. They both utilize the same data sets. Typically, it is just only one algorithm that is used for clinical operations, and this is the one that you kind of like set as your default in the software. You at least it would be very inefficient to actually be switching between algorithms for clinical operations. Okay, here we have extreme weather, so it is necessary to do spot checks seasonally. That's a good question. Typically the machine it is inside a bunker, and within the bunker, I mean, you should temperature setting and all should be relatively constant. So the spot checks, I would recommend that if you have like your routine monthly checks that are done and combined with your daily QA that is performed by the radiation therapist, that should be enough. Any other questions? Let's see. If we add IMRT and VMAT techniques on treatment planning, we need to recommissioning or something? The answer is yes, but the recommissioning is not the entire data collection. It is a recommissioning of a different kind. Essentially, for the case of IMRT, you need to determine your dosimetric leaf gap. If you are using, well, again, variant equipment, which is the one that I am familiar with. And then the other thing is, in the case of VMAT, The techniques as part of the commissioning are, you want to investigate the dose rate, the gantry rotation speed, essentially the leaf speed, and there are specific tests for each one of them. Again, also the dosimetric leaf gap is another key element to all of that. Commissioning for those kind of treatment techniques is can take on the order of 1 week to no more than 2 weeks, in other words. Yeah. Any other questions? Okay, what about brachytherapy commissioning? That's a very good point. Brachytherapy commissioning involves actually a source positioning and dwell time measurements. So you want to establish, or you want to have like some kind of a phantom setup, and typically that would utilize galvanic film, to where you actually would mark predefined dwell positions. And also you need to, for each one of those dwell positions, you also know the time that the source has to stay there. So it is, the focus is primarily on source positioning and the time, and dwell time measurements. So in that regard, it's fairly straightforward. So that's what you would have. And aside from on the calculation portion of it, well, now we have Accuros, for the variant setups. For the other treatments, I mean, you can calculate the dose based on a TG43 recommendations. Okay. Any other questions? Okay, I guess that's it. And we are at 11:22. Sorry, Tia, we went definitely past.
That's okay. Thank you so much to everyone for staying a little longer today. I think this is a really important topic, and I'm really glad that everyone offered their questions. I think they really helped to illuminate some of the important points of the lecture. So thank you so much for your participation. And I'd at this point like to thank Dr. Dante and Dr. Soha for their fantastic lecture. And I want to say good night to everyone in Africa and in the Middle East.
Oh, wonderful.
Yes, and to answer, we can definitely send email addresses to everyone.
Please,
yeah.
do they have one question? When we use 6FFF.
When you use 6FFF?
Yes.
Oh, great question.
Oh, that's a very good question. Okay, a 6FFF beam, definitely, I mean, we have found that we've been using it for our head and neck cases, and it is definitely quite good. And also we've been using it in our long SBRT treatments, because it is a slightly softer beam than your regular 6X beam, with the filter in between. So the fact that it is softer, it is definitely, you have a better, I would say, a smaller penumbra, in particular, for long cases. So and that requires modulation.
So we use it in head and neck because of that the fields are smaller or shorter.
No, because you want to have essentially a little more dose to the surface, to the skin surface. Mm-hmm. So a 6FFF beam actually does a very good job, because oftentimes, I mean, we have seen, in fact, I mean, I did a TLD measurement on a patient that had a tumor. Well, this was not quite a head and neck; it was more like head, a tumor like above the ear. So you want to actually have a not only a beam that that has some penetrating qualities, but also also can deliver a fairly good dose to the surface. So yeah.
Yeah.
Mm-hmm. Yeah, that was a very good question, guys. Thank you. Yeah. Any any final questions before we close the session?
I think we will keep collecting questions through the emails, because this lecture carry out plenty of questions. So I will disseminate to you any questions. And
okay. Then
everyone can feel free also to contact their clinic liaison.
yeah.
So that's Dr. Soha for many of you, and those liaisons can always relay questions back to the lecturers, and the lecturers will respond as quickly as they're able.
Yeah, that would be great. And finally, okay, here Mohammed just said, sorry, brass buildup cap. No, we don't use brass buildup cap during commissioning. Everything is done in water. So all you do is some kind of like you waterproof your chamber. That's basically it. No brass buildup. You need to put up your water tank, and then typically for the PDDs and profiles, you use a CC13 chamber, or you can have like a diode, a specific diode for large fields, and collect your PDD and profile data that way. All right, guys. I think it is time. It's just about 11:30. All right. Thank you so much for your attention, all, and well, have a great evening. Okay.
Thank you, everyone. Good night.
Good night.
Okay, good night. Thank you.
Good night.
Thanks.